Hi kiddos, hope you're doing well. Here's a video in which I would like to introduce the notion of function composition, composing two functions with one another. So here's how it works. Okay, function composition or composing two functions is a way to join two functions in a little different way. So what I'm going to do is I'm going to make a little visual out here, and then another visual out here, and here's what's happening, right? So what it means to compose a function, and here's how we write it. There are a couple ways to write it. One is f of g of x, or sometimes you'll see f and then a little circle, g of x. Right? I like to write it in this way. But what this means, and here's what I want you to get out of the video, is what this means, and then we'll talk about how we can use it in class. But what this means is if we're going to start from the inside out, right? So we start with x. And x will first travel through this function g, right? So here comes x, and let's pretend this circle represents the function g, right? And so whatever g is, it might square it, it might add 3, whatever action g performs, it will perform it. So x is going to travel through g, and then come out the other end as g of x, right? So g will have turned x into g of x, right? The output, right? Now, what it means to compose f of g of x is that now that g of x is going to go through the last action. The last action is the function f. And so this, whatever this is, 4, 12, 1/3, which is the output of function g, is now going to travel through f, and f will perform whatever it does to the function, and out comes this notion of f of g of x. Okay, and that is how one way we write it, right? So let's look at an example. Okay, let's suppose g were x plus 1, and let's suppose f were x squared. Yeah? Okay. So let's look at what the composition of f of g would look like, right? So let's first start with a number, right? So take, let's say, 2. Okay. So let's consider what, for this example, f of g of 2 would look like. Okay. So what we're going to do is we're going to start from the inside out. So 2 goes into the function g, right? So here comes 2, and if it's going into g says, hey, we're going to add 1, right? And so g works its magic on 2, and out comes 3, right? Because g of 2, when you plug 2 into g, it's x, which is 2, plus 1, which is 3, right? So 2 went in here, and it came out after going through g as 3. Okay. Now that 3, and one way we can do this is we can replace g of 2 with what it is. It's 3 over here with the notation. Now that same 3, the output of g when 2 went in, is going to go through the function f. And f is going to square, right? So f of 3 ends up being 3 squared. And out comes 9, which is 3 squared. All right. So therefore, what we just found was that f of g of 2 equals 9 if g, our inner function, is x plus 1, so it adds 1 first, and then to that, which ends up being 3, we're going to square, and out comes 9. Okay? So let's see if we can generalize. Well, what would the composition of f of g of x look like, right? So instead of a 2 going in, what happens when an x goes in? So let's kind of chase it and see what happens, right? There are a couple ways to think about this. So x is going to go into the function g and come out as x plus 1, right? Because that's what g does. Out comes x plus 1, right? That x plus 1, now notice x plus 1 is the output for g, right? That x plus 1 is now going to go into f, right? And f does squaring to whatever it takes in, so f is going to square x plus 1. Right? Now what is that? So f of, f of g of x is f at x plus 1, right? The output of g, x plus 1, becomes the input of f. And so that says, well, we're going to square it, right? Because that's what the function f does. So I'm going to square x plus 1. Right? And what I end up with by foiling, if you reckon, is we end up with x squared. First times first is x squared. And then we're going to get plus 2x for our inners and outers, and then plus 1. Right? So what I've just done is I've evaluated a general rule for if g is x plus 1 and f is x squared, then basically if I have f of g of x, meaning I put the output of g as the input of f, then I end up with x squared plus 2x plus 1. Okay? Let's see if it works the other way. Let's examine g of f of x. Do you think it will be the same? I don't know. Maybe it will, maybe it won't. Let's see. All right? So this time, I'm going to switch the order. So I'm going to start with and work from the inside out. That's how this function composition works, right? So first, x is going through the f function, right? So my little x, start with an x. It goes through f first because we work from the inside out. F is in the inside. And it comes out as x squared, right? Why? Because that's what f does. It squares things, right? Now it's that x squared, it's the output of f, my inner function, that gets plopped into g, right? And what g does is it adds 1 to whatever it takes in. Right? So as x squared goes in to g, I end up with what? X squared plus 1, right? Because g adds 1 to everything. So x squared goes in. So we're going to take x squared, put it in to g, which means I'm going to put an x squared every time I see an x in g, right? So that becomes x squared. And then we just add 1. So look, that's interesting. Function composition is not commutative. It doesn't work in the same way in different directions, or at least not necessarily, not for all cases. Okay? So this is what function composition looks like, right? You work from the inside out. You perform your inner action first. The output of that inner action becomes the input for my outer action, right? Okay, so here's an example I would like for you to consider. Suppose f of x is 2x and g of x is x plus 4. Okay? Evaluate the following: f of g of 2, and then find an expression for f of g of x and g of f of x. Okay? Do your best. Come in with some questions in class. Have a great weekend.